Yo, what's up? What's up, guys? This is Chung here. So this time we're gonna do this LeetCode problem 582 queue process. It it's marked as a medium problem, but to me it's kind of like on a easier side of the medium problem. Okay, let's let's take a look here. So you're given two arrays. The first array is the process ID array, and the second array is the parent process ID of the first uh, process ID, basically here. So the process 1 has the parent ID 3, and 3 is a root, so it will be 0, and 10 has a parent 5, and 5 has a parent of 3, right? So basically just like a tree. We're constructing a tree here. And then you're given a third parameter, which is the process you want to kill. And you need to create write a algorithm to return all the processes once you kill this process. Basically, you need to kill this process and all its child processes, right? For example, this one here, 5. You, you kill 5, so 10 is its child, so you also need to kill 10 here. If you kill 3, basically you're killing all the processes in this tree because 3 is the root node, right? So how are we going to do it? So since we are we know it's a tree, right? So the first thing come to my mind is we have to traverse the tree, right? So you can do it either breadth first or depth first. Either way is fine. I think personally I prefer the breadth first because it doesn't require uh, recursion. So it's we can just do it in the iterative way. So I think first thing you want to do is, because you have the queue here, right? So what you can do here, you can start, yeah, because we have the starting point, right? We know which node we want to queue, and we want to find all its child nodes. So that's basically where we start. We start from this queued node, and then we want to iterate through, find all its child. How, right? The the naive way is we put this one into a queue, and then every time we'll try to find uh, from this PID if there's any, and then we just keep popping the queue from popping the queue, right, to get the current node, and then we just loop through all the PID arrays to find. Okay, so if any array, I'm sorry, if any node is the child of the current parent node, right? But then that will be like n squared uh n squared basically because for each of the node here, right? We're starting from here. For each node, we'll scan through all the PID. That will be n squared, which will be with that basically that will cause the the runtime exceeded the runtime limit. I think LTE something like that. Yeah, runtime exceeded. So basically the key point here is we just need to pre-build the parent and the child relations, right? So in that case, every time when we find a new node, we can only loop through the child node for this current node, not the whole PID array, right? So okay, so basically the first step will be we pre-calculating all the parent and child relations, right? And then we save it into a dictionary, right? Dictionary is a good data structure to store the some relations data, because in this case the key will be the parent node ID, and the value will be all its children, the child nodes, which will be a list, right? So basically we'll define a node dictionary, right? And then it's going to be a default. I use the default dictionary here so that I don't have to worry about the and I don't need to handle the empty dictionary, right? So and the default value for this dictionary will be a list, which will be storing all the child nodes. So then what do? We loop through the parent node, right? And then we enumerate PPID, right? We need the index here because you can see here the index is 1 to 1, right? So we need to find we use the index to find its child, the child node for this node, right? Because we have three here, so we'll be adding this node twice basically, right? That's why what we'll be getting uh, after this for loop. So for 3 we'll have 1 5 0 3 5 10, right? That's what we need. So basically we do a node dot dictionary, and then the key will be the parent, right? The key will be the parent, the node, which is the current node, and then we do append, right? Append to the child node. What is the child node? Child node is the PID, the corresponding position in the other array, right? So this is done, and then we have the process, right? The pre-processed parent-child relations. So now we just need to loop through, find all the child nodes for the queue node, right? What do? We create a queue right here, right? Collections dot dq to dq, and then we push this queue, right? We push this queue node into this queue, and then we just loop through it. We do a breadth first search, right? So while queue, right? Queue, and then we just pop, right? We pop this node, parent node, do a pop left, right? And then we do a pop node, and then we every time when we pop the node, we do a okay, yeah. We also need to have a result array, right? That will be our final result. So every time we see a node, we know it's either like the current the queue node, the node we want to queue, or its child node. So we just add it into the final result, because it says the order doesn't matter, so we can just simply add it there. Right. So once it's done, what do? We find if there's any for the current parent node, if there's any child node, right? So what do? We use the parent node to look for the dictionary, right? To find all that. So here, and then we'll add all those child nodes to this queue so that it can be processed again over and over until this all the child node has been processed. We can use a for loop. We can use a for the child node in that dictionary, and then we just keep appending to this queue. Or there's an easier way. We can just do a queue uh, extend, right? We have an extend here, so we can just extend uh, another array. Basically, that array will be the node dictionary, right? The node dictionary, this uh, parent, right? Parent node, right? So that's it. We keep looking for the child node until this queue is empty, right? And then in the end we simply return the result, right? So that should do it. Oh, typo here. Cool. Yeah, okay. Success. So pretty easy. Pre-process, pre-process the parent-child relations, and then start from this cube node, and then we just try to find all the child nodes, all the child nodes starting from this queue node, and then we simply return the all the nodes we have seen. All right, cool guys. Thank you for watching the video. Thank you so much. Please let me know if you guys need uh have any questions or comment, or if you guys want me to do another problems. Otherwise, I'll just keep doing this LeetCode problems in my own pace. Cool. Thank you guys. See ya.